Alright, so in this video we're going to take a look at a few more examples here of these double integrals over general regions. And for this first one, we're going to do it similar to the previous example where we're going to look at it both vertically and horizontally. So we're going to take this double integral here under this surface where R is our region, going to be bounded by x equals y squared and x plus y equals 2. We'll start here vertically. And the picture that we're going to need is going to be the sideways opening parabola. Looks something like this. And then this guy here, this is going to be our line, y equals 2 minus x. So that'll be a y-intercept of 2, and it'll have a negative slope. So it's going to look something like that. Now, that means our region is going to be this right here. So I'll kind of sketch this out here in yellow. That's going to be our region that we want to investigate. And if we're wanting to go vertically in this case, the thing that you might notice first is that if I put the vertical bar here and we take a look at what the top function is versus the bottom function, we get one outcome. But if I put the vertical bar, let's say over here, now my top is different. And so we've seen stuff like this in Calc 1 where we have to transition from one function to another, and so that's exactly what's going to happen here. Now, to get this thing started, we'll go ahead and put the double integral, and we're going to need to remember that since we're going vertically, it's going to be a dy dx problem, and so what I'm going to have on top of the first integral would need to be a y equals something, and a y equals something there. Now, because of how our functions are given, we're going to have to go ahead and solve each of these for y. So this first one would be y equals plus or minus the square root of x, and the second one would be y equals 2 minus x that I mentioned before. So for this top one up here, if I look from this guy over to where, let me sketch this in to make it look a little bit better. If I look at this guy as I transition from here over to the blue line where that transition is going to be, my top is going to be the top part of that parabola, which would be the positive square root of x. My bottom from here all the way over to the blue line where we would transition would be that bottom parabola, which would be the negative square root of x. Okay, so we've got those in place. Now we would just need the actual numbers, which would be the points of intersection. So if I take over here to the side, if I take this 2 minus x equals plus or minus root x, it's really not going to matter the plus or the minus. If I square both of those, you can see how the plus or minus essentially goes away. I've got a 4 minus 4x plus x squared equals x. That's going to be an x squared minus 5x plus 4 when I move things around, which factors into x minus 4 and x minus 1. So we end up with x equals 4 and x equals 1. And both of those make sense. This is clearly going to be the 1 right here, and this is going to be our 4 that we'll need to use a little bit later. So for our first one, here and here, our x's are going to go from 0 all the way over to the blue where they intersect at 1. So that's going to be a 0 to 1. I will go ahead and drop the actual function in there as well. That's going to give us a 6x plus 2y squared. And so that's going to be now our first part right here. And then we need to add our second part to that. So we're going to have a plus double integral. I'll go ahead and drop that function in there again. It's still going to be a dy dx. And now, when we have our y equals and our y equals here, now at the top is going to be the line. So that line is going to be the 2 minus x. And then the bottom here is still going to be that bottom half of the parabola, so it's going to be the same, y equals negative root x. And then for our numerical bounds, here and here, That's going to be from where we left off, which would have been at 1, and then we would continue on from 1 over to this point of intersection, which would be 4. So that's going to be our 1 to 4 right there. So you can see to compute this area right here, doing so vertically, you would have two separate integrals you would need to set up. You'd have the first one plus the second one, and when it comes to evaluating, you would of course need to evaluate both of those. And so fortunately, we have some decisions we can make, and if we don't like what vertical has done for us, we can now apply the horizontal technique and hope for a better outcome. So I'm going to go ahead and shrink this down a little bit and move this. And then we can take a look at how to do this horizontally. Now, our picture is going to be the same. We're still going to have our sideways opening parabola. We're still going to have our line. And we're still going to have our same region right here. The difference now is that we're going to draw our line horizontally in there. So if I draw this in horizontally, what you'll notice, hopefully to start, is that if I scan from up and down this vertical line, the right is always this line and the left is always this sideways opening parabola. So we're only going to have one integral here, or one double integral here, that we need to worry about. So to see how this is going to need to be set up, we'll go ahead and put our double integral. We're going to have our function 6x plus 2y squared. And then we also know that since it's horizontal, it's going to be a dx dy. We want to finish with y because these are going to be constants. That also means this is going to be an x equals right there and an x equals right there. And we've done a little bit of work already to see that our line here would be our right. Our line from above would now need to be x equals 2 minus y. So I'll go ahead and put the 2 minus y in. And then the left would be the sideways opening parabola, which in this case was already solved. That's going to be x equals y squared. So now we need are the constants. The constants are going to be found, and as a reminder, you can certainly do this. These constants are going to be y equals. So what we're going to need is to set these two things equal to each other, but we're going to need to solve for y. So I'll set y squared equal to that 2 minus y. That's going to give us some y values that we can then plug in. So moving some things around, y squared plus y minus 2 equals 0 would factor into y plus 2 and y minus 1, which would give us a y equals negative 2 and a y equals 1. Both of those also make sense where we have the positive 1 up here and the negative 2 down here. So I'll go ahead and plug those into negative 2, and 1. And there sets our setup for this particular one going horizontally. Now, obviously, if you have it's up to you to make the decision. This is the route you'd want to go to avoid having to integrate both of these. And so I'll go ahead now and clear the screen, and we'll go through the actual integration of this. And whatever number we get for the final answer, we would get for the same one, but this one's going to be far more efficient. All right, so all I've done is clear the screen and copied down the integral that we're going to work. And so you'll see we're starting with dx, which means that we're going to integrate this single integral that I have in green now. We're going to integrate this with respect to x. So this whole thing here would be a constant. All right, so let me go ahead and say that we have a single integral now from negative 2 to 1, and that's going to be a 3x squared when I add 1 and divide with respect to x, and then we'll have our plus 2 xy squared. Since that was a constant, the x pops up, knowing that if we go the opposite direction, we would in fact end up with the same thing here. So now we are evaluating this from x equals y squared and x equals 2 minus y. Still want to put our dy back here. And I've said this many times, but I'm a big fan of putting the x equals here to remind myself that I'm only plugging it in for the x's, not the y. So we'll have a negative 2 to 1. We'll have a 3, a 2 minus y squared plus 2 times 2 minus y. times y squared minus the quantity, 3, this will be y to the 4th. So when I plug this guy in here, that's going to give us y to the 4th. And then plus 2 y to the 4th. So I plug my y squared in right there. Y squared and y squared give us a y to the 4th. Fortunately, we can combine these. Now, I'm going to go ahead and do a couple things in this next step. And this is where you're probably getting your real first taste at how messy some of these things can be if we're not careful. But we're going to have to multiply this thing out. We're going to have to clean it all up, and we're going to have to continue on. So it can be a little bit of a mess, but as we saw in the setup, we can hopefully avoid a lot of it. So when I go ahead now and move into the next step, this is going to expand out right here into 4 minus 4y plus y squared. I'm going to distribute the 3 into that as well. So maybe I'll write that above it. This, when you multiply that out, it's going to be 4 minus 4y plus y squared. I'm taking the 3 into that. So that's going to give us 12 minus 12y plus 3y squared. I'll also go ahead now and distribute both of those numbers in, which is going to give us a plus 4y squared minus 2y cubed, and then finally a minus 5y to the 4th. The minus 5y to the 4th comes from this right here. And then we'll have our dy. And we can still clean this up a little bit more. We'll have our 12, we'll still have our minus 12y. Now we're going to have a plus 7y squared when I add these things together here. And then these two will remain unchanged. I'll just copy those down. So minus 2y cubed minus 5y to the 4th dy. All right, so finally now we're ready to integrate. And being as a polynomial, we're just going to add 1 and divide on each of these. This will give us a 12y minus 6y squared plus 7/3 y cubed minus 1/2 y to the 4th, and then minus y to the 5th being evaluated from negative 2 to 1. So this is, again, now it's a bunch of number crunching at this point. I'll go ahead and write it out, but you can certainly probably see this pretty quickly. We've got a 12 minus 6 plus 7/3 minus 1/2 minus 1 minus the quantity now. So now I'm getting ready to plug my negative 2 in for all these y's. This will give us a negative 24 for that first one, a negative 24 for the second one, a minus 56 over 3 for the third one, a minus 8, and a plus 32. So lots of numbers there, but it is just evaluating. And this ends up giving us a 99 over 2 for the final answer. And if you'll remember, that 99 over 2 would be the same answer you'd get from the previous screen where we set up the volume computation vertically, and we had those two different integrals. And so this one was far easier, but we still got the same answer. So you'll see here again, evaluating these is really no different than over the rectangular regions, except now you have functions here instead of just numbers everywhere.